Cold or warm water?
Make you guys a little smaller. There we go. All right. So our first step is we're going to fill our bottle about a quarter of the way up with water. So just a
Quarter. Almost.
Not halfway, but about half of a half.
Half of the
I'll
half.
show you what I mean here.
Hold on.
I have my water. Pour it in. About a half of a half.
Okay, more
than a quarter, but it's okay.
More.
However you do it is just fine. Just make sure we leave some room for our oil.
Okay.
Okay?
More. You can
so we
finish
have our
more.
water in our bottle or our jar, whatever you are using.
This is half. She said not
All right.
half.
Are we ready for step 2?
Okay.
Awesome. Lots of thumbs up there. All right, so step 2, and if you're on the near pod, I'm still flipping through the near pod. I'm just sharing the screen. Our second step
Can I put it
is
in?
that we're going to fill the rest of our bottle with our oil. Okay? We're going to take our oil here,
Oh no.
and we're going to fill it up to the top without overflowing it. Right? All right, as you pour it in there, I want you to look at what's happening.
Oh, it's
Look
getting.
at what's happening
I
with
need
that
more.
water and oil.
I need more oil.
Taking a minute just to load it. Here we go.
Look,
The
Did you put
question
this one
is,
here?
did the oil and water mix when you combined them? So if you're on the near pod, there is a collaboration board question that says, did the oil and water mix when you combined them? So I'm seeing a pretty unanimous decision up here of no, it did not mix. So when we poured in the
Chemical
oil,
reaction.
we're saying it did not mix with the water. I wonder why it didn't mix with the water. Mix. I hope you guys like my little picture. Hey, oil, you want to hang out? Oil says, I can't mix with you guys. The other water droplet says, hydrophobe. I know, it's corny, but it's cute, right? It gets the point across. So oil and water does not mix because oil is hydrophobic.
Okay, just
it's
pick it up,
scared
that
of the
one.
water.
Do not
And the
touch
reason
it.
it's scared of the water has to do with the molecules. The big thing here is the differences in our density. Remember we talked about density and how it's just how the molecules are packed in those different substances. So when we look at oil and water, the molecules are packed differently in the two substances. Okay?
We need to have that one.
So
Just
when
coming.
we think about density, remember at the beginning, we said
Make the
that
half.
if it's more dense, it's going to be tightly packed and it will sink. If it's less dense,
Half.
it's going to be loosely packed and it will float.
Okay, that's fine for now.
So if we
Okay.
think about this, more dense meaning it
At least
sinks,
they can
less
fit.
dense meaning it floats. What do you think the oil is? Do you think the oil, since it's floating on top of the water, would be less dense?
Oh no,
or
they
more
put water then
So we
oil.
said, think about what we just put on here. We said if it's more dense, it sinks. If it's less dense, it floats. So if the oil is floating, what would that mean?
It's less
You
dense.
guys are awesome. Oh my goodness. Yes, in the chat, see you guys. Yes, the oil is less dense. The oil is less
It's
dense.
like a puzzle piece.
So the oil is floating on top of the water because it's hydrophobic. It's less dense.
Marky, what's
All right, let's keep going. Are we ready for our next step? Awesome.
Careful.
Our next step,
Careful.
this is the fun part. We're going to add, actually, it's not the funnest part, but still fun. We're going to add our food coloring. Okay? So I'm going to add my red food coloring here.
Woo!
And I'm
Go,
going to
go.
add several drops down in here. Now, as you're adding this food coloring, I'm adding quite a bit here. Being a little dramatic with my food coloring. Okay? As you're adding the food coloring, I want you to be observing, making those scientific observations about what you are seeing, what is happening. And I got some on the edge there. Okay? Make some observations about what you're seeing. Did the food coloring, did it stay in the oil? Did it drop down to the water?
It dropped down to the
What
water.
are we seeing? Okay? But you guys are absolutely right. It went straight through the oil and went into the water. So as you can see in mine, my food dye, my food coloring, is mixed in with the water at the
I hope the
bottom.
Alka-Seltzer fix it.
The reason it went straight to the bottom is because it's more dense. The most exciting part of tonight. Are we ready?
Oh no, maybe
We
it's
ready?
getting coming
Okay.
down.
We're
Hold
going
on.
to take our Alka-Seltzer tablets. We're going to take our Alka-Seltzer tablets. I'm going to cut mine open here.
Oh, she had the same as us.
All right.
Oh,
And I'm just going to
another
break
one.
mine up into a little bit smaller pieces here.
Oh yeah, they're the same. Oops. I accidentally scooped some more.
Hold on, Marky.
Okay. So I hope you can see it. I've got my Alka-Seltzer kind of broken up into smaller pieces here, and I'm just going to drop them
Oh
in
no,
one
it's
at a
gonna
time.
be.
Now, I want
Hold
you guys
on,
to
let's see what
observe
she has.
Ah!
It's react.
And I'm just going to keep adding a few.
Oh, I need more.
Yeah, you can put that.
Oh.
Look, that is beautiful.
What are we seeing? Ooh, I saw some people saying it's making the color rise. Making the color rise.
This
Gonna
is so
add some more in
cool.
here. Now, what?
And hold on, where's the flashlight?
Do they stay up?
Where's the flashlight?
Here.
Oh,
Hello, I told you, see, it's come out now. Here. Go, faster. That's why it's lava.
Go up. They're not staying up. They're falling down. I wonder why. Whew, I might have put up too much Alka-Seltzer in mine. Mine is, whew, wow. It does look just like a true lava lamp.
You want to put
Absolutely.
some more?
that's
No.
fine.
You guys, just take a minute. Let's observe our lava lamps. Appreciate what we've done. Ooh, Mr. Smith, your green looks good in your bottle.
I think I put too much.
No, you need to. Can you take your color, your blur? Where's the blur here? Where's the blur?
Here.
See, let me get a wider view here so I can see more of them. What do we notice? The longer it sits there, does it keep moving just as fast as when we first put it in there? What do you think?
Put it down a little bit.
Ooh, it's fizzing. I like that.
Flashlight, the flashlight on the back.
when you add more Alka-Seltzer
It's
tablets?
coming out. Marky, what happened there? The answer. What happened?
What happens?
Okay, give me. What happens?
Ooh, I see some people said some of their bubbles escaped. You must have filled
Where's
this
the mouth?
bottle up really tall, really tall. Ooh, some people said it speeds it back up. So it had slowed down, right? But when you add the Alka-Seltzer tabs, it speeds it back up. There's more bubbles. It's fizzing even more.
Here, hold.
More Alka-Seltzer.
Absolutely.
Marky, the flashlight. Put it down.
What do you notice? The more that you add, does it move faster or slower?
Oh, pasta.
No, you don't have to shake it up, Camille.
Put it in the middle like that.
Yeah, the more Alka-Seltzer tabs we add,
Oh,
the more of a reaction there is, right? The faster those bubbles are generating and going to the top. Absolutely.
Oh my goodness, it's gonna slip.
Awesome.
yeah, that's why I put that there.
All right. So when we add these Alka-Seltzer tablets to our bottle, we're creating a reaction between the water and the Alka-Seltzer tablet. Right?
What is
And it creates what we call carbon dioxide. Okay?
Mark,
How do you think you were able to see this gas? What do you think was showing the gas moving throughout the bottle or the jar? How do you think it was being represented here? What do you think? What do you think is being represented?
It looks so cool.
How do you think we're representing the gas? Oh, I see you guys in the chat. Yeah.
Okay, just close now, Mark. Eh? Oh, do not
Absolutely.
open up. Close now, close now.
Yeah, so we're able to see
One
the
more
gas
Alka-Seltzer.
by the
One more.
bubbles. All of those bubbles that have been created and are moving up to the top. That is our carbon dioxide. That is our gas.
Marky, bubbles.
Yes,
Did
Mr.
you?
Smith, carbon
come
dioxide
on?
is what we breathe out. Absolutely. Absolutely. Yeah, and the more that you add, the more reaction you have, the more carbon dioxide there is, the more bubbles there are. Why do you think the bubbles eventually fall? That one's tough.
My masterpiece.
Yeah, it's moving a lot.
Oh,
In the middle only.
Why do you
Marky.
think the bubbles eventually fall? It's a tough one.
oops.
So if gas is what's making those bubbles
We're gonna
move up to
close
the top.
Little bit.
Oh, I see Brantley.
Okay.
They are water. So that carbon dioxide that's
No, I
rising to the
know.
top is the mix, right? And when that carbon dioxide escapes,
My dragon boat.
it's now just water again. And it causes it to sink back down. Absolutely. Little scientists. I'm telling you, I love it. All right.